Hello, welcome. Welcome to this early morning session. Today we are going to talk about operating serverless apps and function with Stackdriver, with Google Stackdriver. I am Steeren. I'm a product manager on cloud, currently working on our serverless product. Actually, before that, I built Stackdriver error reporting.
And good morning. Thanks everybody who braved the Thursday morning after the party and made it to the session. My name is Jay Judkowitz. I'm in product management for Stackdriver. I have a long career starting with back in IT in the late 90s, and so I've always been very fascinated with how we make things better, more available. And so we're very excited to bring that knowledge and awareness that Google's built up and bring it to serverless apps through Stackdriver. So quick agenda. First, Darren's going to give a good overview of serverless, why serverless matters, what our runtime choices are at Google and how to pick one, and then why monitoring in serverless can be hard at times. We're going to switch over to me, and I'm going to talk a little bit about what Google has learned from its 20 years in the business, and particularly the SRE discipline, which we're trying more and more to bring into Stackdriver. And then we'll bring that all together. We'll talk about how SRE knowledge works in Stackdriver for serverless, and we'll intersperse demos with the whole thing and not just 2 slides.
Thank you, Jay. So what is serverless? You might have attended some other sessions about it. Let me recap today. The few characteristics that we use to define serverless products on Google Cloud. The first one is that a serverless product is for developers. Users of a serverless product focus on delivering business value, focus on code. The provider takes care of the rest. This is a key characteristic. The second one is that it scales. It scales to 0, which means if you don't use it, it will slowly scale down to 0. But if you use it a lot, potentially, it scales with you. So really, there is no provisioning to do in advance, nothing, no management of number of instances. This is done for you automatically. The third characteristic is that it is managed. So by managed, of course, the cloud provider is taking care of the infrastructure for you, is taking care of the updates of this infrastructure, of the reliability of this infrastructure, but also of the security. And we provide a lot of security features for our serverless products out of the box. So managed security too. The last point is a billing model. You really pay for what you use. So because it scales, because we have this operational model where it scales up and down, following your traffic, your needs, we are able to provide you a billing model where you only pay when you use it. So as a consequence, you don't need to commit to a certain usage in advance. You do not need to provision a certain cluster size. No. It's all based on what you need at a certain point in time, and you will only pay for that. If you take those characteristics, you can see how it applies to more than just small snippets of code in the cloud, more than just functions. If you take those definitions, you can see that we can apply these to many areas, like database, like storage, like AI, like data processing. All of these, Google Cloud has products that we qualify to be serverless because they answer those definitions, those points. So you can see on the data storage side, one product I really recommend that is a great pair with serverless compute is a Cloud Data Store. On the file storage side, we have Cloud Storage, PubSub, Cloud ML Engine, BigQuery. All of these, you do not have to care about the infrastructure. You really pay when you use it. So all of these are what we qualify serverless. For this talk, we are going to focus on serverless compute. So today, our 2 generally available products in Google Cloud that are serverless compute are Cloud Functions that we announced to be generally available yesterday, and App Engine that has been here for a while and loved by many customers. So these are our 2 serverless compute products, And recently, we introduced a newcomer in this picture, which is the GKE Serverless add-on. So here, to be clear, the GKE Serverless add-on allows you to get a serverless developer experience within your own Kubernetes cluster, but it does not provide you the serverless economics. However, all of the other attributes are available for this product. So it has been announced yesterday and is currently in alpha. So this is the serverless compute picture of Google Cloud. Now I'm going to help you a little bit picking between these, because I can acknowledge that this might not be easy sometime. And well, the first one, Cloud Functions, as the name says, the unit is the function. So here you are going to really think about not something that does many purposes, but only one thing. So it's really well tailored for single-purpose microservices. And because you can trigger a function not only via HTTP, but also via events, it will be a good fit when you want to do asynchronous workloads or things that react after something in your cloud architecture has triggered. So everything that is event-based and async are a good use case for Cloud Functions. Regarding event triggers, we keep adding more and more. You can, to mention a few, you can trigger a function when something, of course, when there is an HTTP request coming in, but also when for certain logs, for pub/sub events, when there is a database change. Like recently, we announced the availability of Cloud Firestore events for Google Cloud Functions. You can trigger a function when there is a new file in cloud storage. So really many events, and we are going to keep adding more over time. This is Cloud Functions. The second product I mentioned is App Engine. So App Engine, the unit here is an application. So an application will be source code that you deploy and deploy to App Engine. The workloads that you deploy to App Engine are triggered via HTTP. So that means that HTTP coming from the outside world. So if, for example, you are going to create a mobile API or just a website with a front end and multi-purpose website, then App Engine is a very good fit. Also, those HTTP requests are coming from the inside. So you might have an architecture with many services and services talking to each other, and they obviously can use HTTP to do that. So App Engine will be best used when you migrate an existing code base, because as we've announced yesterday, we now have what we call the App Engine second generation runtimes. And those are what we say idiomatic. So what does that mean? Is that you can take any module in your favorite programming language and bring them on App Engine. And it's all serverless. So if you're a Node.js developer, you can use any NPM modules from NPM, be it a regular one or a native one, like something that uses binary code. You can do it on App Engine Standard now. And we announced recently the availability of Python 3 and PHP 7 on App Engine Standard. So also something that really scales down to 0 and scales with you to snapshot scale. App Engine has been here for a while, but if you take the characteristics of what a serverless service is, App Engine is serverless, App Engine Standard. And the last newcomer is the GKE Serverless add-on. So here, the unit is the container image. So of course, the add-on allows you to build from source to image, but at the end of the day, the things that are running and scaled for you are container images, even if you build them from source using our tooling. So when will you pick that one? You will pick it when you're coming from a Kubernetes world and you want to give to your developers in your organization a serverless experience. Right? Developers should not have to worry about pods and replica sets and scaling those pods. No, they just want to deploy code and they want things like the system to handle the rest. And this system is what the serverless add-on gives you. So you'd take it when you already have a GKE cluster, when you want to stay in it. You would pick that when you have some special needs of resources that App Engine or Cloud Functions do not give you. So for example, custom VM sizes, or you want to access GPU, or you will pick that, for example, when you want to be close to another workload that is already in GKE. So let's assume you have an Elasticsearch service running on GKE. Then if you want your serverless workloads to be close to it, then this would be a good fit. So the GKE serverless add-on is currently in alpha, but all of what we are going to talk about later apply to it too. So this is a picture of serverless in Google Cloud. However, there are some challenges monitoring serverless. The first one will be that by definition, the servers are not accessible. So that means a few things. That means that you don't control, for App Engine and Cloud Functions, you don't control the OS. So if you, for example, have to install a particular agent, monitoring agent, you can't. So that presents a challenge. Also, in the past, we just SSH into an instance to see what's wrong. Well, you can't in Cloud Functions or App Engine. This is not something we give you. You cannot just SSH the usual way. So we'll see how we provide tools to address that. Then serverless encourages to break the monolith into independently scalable pieces. Because obviously, if those pieces can scale up and down to 0, then breaking them into pieces will be a better economics for you. If each of them can scale to 0 when you don't need them, that's what you will be looking for. So as a consequence, serverless encourages microservices. And microservices mean that you have more pieces to monitor and operate and to trace between all of these. So we'll see how we can help with that. Another point is auto-scaling. As I said, a serverless product scales with you. So when you don't have any requests, there's no instance, so there's nothing to monitor. And when the traffic comes in, then instances are scheduled for you. And then automatically they are stopped when it's needed. Also, you cannot rely on the fact that an instance will be here a long time. No, instances are spin up and stopped very frequently in serverless. So what does that mean? That means that first, you really cannot look at the instance level. You really should look at the service level. The second is that cold start matter. As you know, if instances are started and stopped very frequently, then you cannot do a lot of things at startup time. So you cannot load many modules, many monitoring agents when things start. And for functions, it's even going one step further, which is that in Cloud Functions, outside of the execution of the request, you cannot do anything. So that means that you cannot expect to have CPU outside of the request response time frame. So that's also a challenge. And lastly, serverless, as I said, allows you to build asynchronous workloads. Here, for example, you can react to an event. You can use a queue to enqueue some tasks with cloud tasks that we released to beta recently. You can use pub subtopics to send events across your microservices. So all of this makes it harder to see what triggered what in your microservices. So now we'll see how Stackdriver, so we will see later how Stackdriver can help you address those challenges. Jay?
Thanks, Darren. So, like I said, Stackdriver is really, really fortunate to be a part of Google, where we have at our disposal the whole SRE team to learn from, to see how they built Google to where it is. And did everybody see the book that they released, and revision 2 just came out? So I definitely encourage that. It's really good reading. So what did we learn from SRE, and how are we taking advantage of that? So Google has 8 services with 1 billion or more users. We have 2,500 SREs. And the math doesn't really work this way, but that's over 400,000 users served per SRE, which is incredible economy of scale. And not only that, the SREs have a great culture and love their work. And so this is a thing that customers have come and said, hey, we'd like to be able to have a great ops culture that scales and really takes care of our customers. Now, to do this, they've had to solve really one huge trade-off. On the one hand, reliability. Google.com is sort of synonymous with, is my internet up? It's pretty reliable. But on the same side, on the other hand, they're trying to figure out how to keep Google engineers as productive as possible. How can we experiment? How can we release? How can we put out new functionality? And as you know, change is the biggest thing that affects reliability. So balancing between those two things is the main challenge of SRE and why they've developed the culture they have. So I'm not going to do a whole SRE talk. That would be an hour on its own. But I'll say from the Stackdriver side, what have we observed about SRE that's special and different, and what are the ingredients that are needed to pull together? So the first piece is culture. SREs aren't running around with a pager, playing whack-a-mole with problems all day. That would just not scale, and they wouldn't be happy either. In fact, most on-call shifts only result in a couple pages a week. What are SREs doing then before an incident? They're working on automation, right? Automating all the monitoring, automating all the data collection, automating all of the responses to simple problems that can be handled without human intervention. They're also helping the application developers engineer the reliability into the product. They do the production readiness reviews. They say whether something is ready to go live at huge scale. They say whether it's really worthy of having the pager taken by the SRE team. They're also responsible for, when there is an incident, the incident response process. We won't talk about that here, but that's in the book. It's a really interesting, scalable, predictable system in the face of what could be chaotic events. They're responsible for the blameless postmortems, which are really important because you're never going to keep improving reliability and agility if you're not able to look back at problems and see what caused them without people being afraid of some kind of repercussions. Now, the most important part of what the SREs work on is SLOs, the service level objectives. That drives everything we do and drives how we think about reliability. I'm not going to describe that here because there's a slide and a feature that will go into that in detail and apply that to the serverless products. Now, if you're an SRE team and you're outnumbered by over 10-to-1, and everything you're doing is data-driven, particularly SLO work, imagine a conversation where you go to all these engineers and say, I want you to give me this metric, this log, this thing, that thing, and I want you to do it, and keep up with my thinking on how monitoring should evolve. It'd be a short conversation, right? It's pretty hard to get all these people to give you all exactly what you want. So at Google, what we did is we baked this into the infrastructure. When a Google developer deploys a service, that service is well-defined, it's discoverable, it has an identity, things like quota and permissions are config on that system, and there's automatic telemetry. The same telemetry from there's a baseline of telemetry that every service has that comes from the infrastructure that the developer doesn't have to worry about. This keeps the developers very productive, and it keeps the SREs full of the data that they need, and removes a fundamental tension that could be there if we weren't careful about that. Now, you don't all work at Google and don't develop on Google infrastructure, but we've baked these principles into the serverless runtimes. So functions and App Engine and the serverless add-on, the GKE, all return standardized metrics that can be used in a standardized way in the Stackdriver dashboards that we'll be showing. We've also open sourced other nifty things inside Google that are pretty helpful. So Stubby is our secure RPC mechanism. That's open source to gRPC. And Census, our system for our open source library for collecting metrics and traces. That's been released as Open Census. Now, Google's a big place, and so if every app is automatically getting all these signals sent, that turns into a lot of stuff. So we have petabytes of logs every day billions of monitored resources, hundreds of billions of time series. Where does that all go? Well, you need a platform that scales to handle that. You need to be able to store it, keep it safe, query it, do analytics on it. And we're not going to talk about this, it's not the topic of the presentation, but note that that is the bottom half of Stackdriver. When you use Stackdriver, you're putting your metrics, your logs, your traces in the same robust and scalable systems that Google engineers are. The last piece, and this is where we're really going to focus, is the tools. It's kind of the tip of the iceberg, right? Everything that I talked about before is that giant iceberg under the water. What's above the water is the tools. How do I implement this operational culture, taking advantage of all this data and doing useful things? And that's what we're going to go into detail about and demonstrate for you is on Stackdriver front end. So what tools are available for serverless from Stackdriver? So what are the columns? First is monitoring. This is basically your metrics, whether it's coming from the infrastructure or custom metrics coming from the app. It could be uptime checks, it could be log counts, but all these metrics are stored. They're queryable. You can set alerts and notifications on them, create incidents when they go out of whack. And so that's the core piece that you expect from a monitoring solution. Then there's logging and error reporting. Logging is collection of logs. Error reports are special logs that are tied to stack traces and oftentimes, and you want to do special analytics on. Lastly is application performance management. That is our tracing product. Distributed trace we'll talk about. Our continuous profiler, which helps you manage costs. And the live debugger, which lets you figure out the state of your application down to the variable level without pausing, redeploying, or crashing the app. As you can see, green check marks all across the board for App Engine. We supported that for quite a long time. In fact, a lot of these products supported App Engine before they supported anything else. Cloud functions. Monitoring, logging, error reporting work, no question. The APM tools also work. But some of the libraries and instrumentation need to be optimized for the function world. So I definitely encourage people to try it out, and may or may not be ready for production for your app depending, your functions depending. Lastly, GKA serverless add-on. The Stackdriver team and the serverless teams are working very, very closely to make sure that these all work by the time we go to public beta. As of the alpha state, it's still in progress. All right, so let's look at this in action.
So before,
basically we have an application, and that application we're going to do things to it, and the demos will show how the monitoring features come into play. But Staren wrote this, so let's let him describe the architecture.
All right, let's see what the app does, and then I will explain you how it's done. So simply, this is a website. The title is Web Page Watcher. So what this website does is that you submitted a URL of a web page, and then it will watch it for changes, visual changes. So for example, on this test example app, I wrote a static web page that, from the button changed color. And as you see, my web page watcher website captured those two, what we call keyframes. So there was a change, they were captured visually. So let's switch back to the slides to see how we built that using serverless products. So the first thing to know is that every 5 minutes, there is a cloud scheduler, which is going to trigger another service. And the service is what we call our task scheduler. So the task scheduler will query the database for web pages to watch. So the database will return, OK, I have this set of web pages, and go watch them. The scheduler for each of those web pages will create an event in Cloud PubSub, and this event will be take a screenshot of that page. So one event per screenshot to take. This is the only job of that service. The second service has only one job, taking screenshots of the web page it gets. So this other service is written in App Engine. We could have written a Cloud Functions for that, because both App Engine and Cloud Functions support all of the libraries that you need to run headless Chrome. So this screenshot service is running Chrome without a visual interface, but it's rendering a web page, taking a screenshot, and that's it. That's the only job of that service. Super simple, like literally hundreds of lines of code. I'm not going to show them, but very simple to write. Once it took a screenshot, it will store it in cloud storage. Simple. And anytime something is added to that cloud storage bucket, an event is triggered. And this event will trigger a cloud function. This cloud function also has only one job. It's comparing the new file with a reference file. And if there is a difference, it will store this new screenshot as the new reference, and it will capture it as a keyframe. So here, if there is a difference, it will keep the new image that it just received. That's basically what's happening every 5 minutes. This is configurable with Cloud Scheduler. And then when I open my web page watcher website as a user, what I'm doing is I'm hitting a front-end service that is a regular website service that queries, of course, the database to look for the web pages that we are tracking. And also, when I look at the details of one of those web pages, it will query the cloud storage to return the keyframes of that web page. So you see, 4 services, 4 microservices, each of them super, super simple, but brought together, they are doing something very complex in a very reliable way. And so this is our demo app. And now Jay is going to go over the first scenario for monitoring and troubleshooting this app. So what you should know is that I did a release of that application 30 minutes ago. So let's see if this release is healthy.
I'm sure it's going to be great. So we're going to talk about 2 features that are going to come into play in the first demo. The first feature is an SLO feature. So this is, like I said, I deferred earlier that we're going to dive into this. SREs, like I said, they don't chase around problems playing whack-a-mole with the pager all day. Because again, the toil would be too high and the scale wouldn't be there. What they really worry about is what affects the customer directly. So let's look at a very trivial example. What if the CPU runs hot? Well, that could affect a customer, but we've done the obvious automation there. We've implemented auto-scaling, it scales out, the CPU drops, and if there was any degradation in performance, it goes away. There's no point in paging somebody. It works, right? But no matter how much automation you do, no matter how much thought you put into the system, you always make it better and better, but you never get rid of every last problem. And so at some point, there's something you didn't automate away, and it affects the user. And that's what the SLIs are about, is quantifying the effect to the user. So what does the user care about? Did they care about your CPU? No, not at all. What do they care about? They care about 2 obvious examples: availability. What percentage of my calls come back with a 200 response? They care about latency. Let's say a particular service works well up to 300 milliseconds response time. So I care what percentage of my requests come back in 300 milliseconds or less. So those are indicators. Those percentages are the service level indicators. Now once you know what it is you're watching and what it is your users care about, you put an objective on that. And that objective is sort of the promise you're making to yourself, whether you externalize the promise or not, saying, this is how I know my thing is working. For example, I might want 99.9% 200 responses, or I might want 99% of my calls to come back in under 300 milliseconds. Now you notice in those examples I threw out there, I didn't use the number 100. And there are a couple good reasons for that. One is, if you needed 100%, you'd have 0 flexibility to do anything, and any change anywhere that broke anything would break your promise. So 100 doesn't often make sense. But second, people are pretty good at writing apps that are resilient. You get a 500, retry. It'll probably work. Web services, like if you go to a web page and 99 out of 100 times it loads satisfactorily and the last time it doesn't load satisfactorily, you'll be okay, right? So having a non-100% SLO is really, really important concept. Now, when you subtract the objective from 100, what you're left with is the error budget. That is how many calls you're allowed to have that, in an availability case that aren't 200, or in a latency case that are that are slower than you'd like. And by the way, there's other SLOs and SLIs out there. I'm just going over the most common ones. And the error budget is a critical thing. SREs really, really, really focus on this, because if your error budget is low or below 0, you should stop adding features, right? You should start fixing technical debt. You should hold off release. You should fix the system and make it more reliable. What if the error budget is super high? Well, crank up the dial. Just say, hey, we're not experimenting enough. We're giving the users more reliability than they need. And that seems like it would be a good thing, except for 2 problems. One, they could start relying on that, and you may not be able to maintain that. Or 2, you may not be giving the features they want, because your customers want reliability and they want features. So make it as reliable as they need, and then get as many features in as you can. Spend your error budget, like your money budget, right? And then what if your SLO is okay, like you haven't broken it, but it's dropping precipitously? Well, that's when you page somebody. If you have a precipitous drop in error budget in an SLO for an indicator that a customer really cares about, that's when the SRE gets woken up at 2 in the morning. Now, I've grayed out this third concept, SLA, because it's not really an SRE concept, but it's a business concept, and people ask about it in this context. SLAs are when you give some kind of guarantee to your customers and some sort of, maybe like I'll give you a refund if I don't meet this SLO. By and large, again, like I said, not an SRE concept. Obviously, the advice here is if you have an SLO tied to an SLA, you should probably have a much stricter SLO internally that you're not publishing, because you certainly don't want your finance and legal to be the ones notified the first time something goes wrong. You want to work really, really hard to keep customer happiness high, and then have your money back guarantee at a higher level of dysfunction. So feature number 1 is going to be that SLO feature. Feature number 2 is an integrated service dashboard. So Stackdriver has a lot of pieces, and I kind of rattled them off before. And they're all really awesome, and independently they all add a lot of value. But they're all in different pages, different domains, right? I have a dashboard page, I have an incident page, I have a log page, I have an error report page, a trace page. But if I'm monitoring a particular service, what I really want to know is what are all of the signals that I have for that one service, and put those all in one place and be able to have an integrated troubleshooting experience that goes from I have an SLO problem to here are my metrics, to here are my logs, and go deeper and deeper. And so that's what we've put together. So let's do demo 1. Let's have a bird's eye view of microservice and see what's going on here. So what we're looking at is the screenshot service. You can see the name here. Here you can see the timeline. I can zoom in to a particular time. We'll show that later in the demo. We have an incident history, event history, and like I said, we're going to start with the SLOs, because the SLOs are what we're managing to. Like, we're not managing CPU or memory, we're managing to the SLO. And we have an SLO that says we want 90% availability in the last 7 rolling days. And as you can see, we were doing pretty well. We had a big hiccup yesterday. I guess Stern and I were practicing the demo. And then we were doing really well, and there was this little blip. I'm not sure what that was, but blips happen. It's a small one, and we survive it. But something bad is happening right now, right? We're definitely not getting 90%. We're something like 60% of successful responses. And the error budget, accordingly, is low. So we've been playing with this over the last week, and we're under 0. If it really looked like this in real life, everybody would all hands on deck for a reliability surge. But right now, you can see the error budget, even though it was below 0, it's dropping even further. And then we can look at the metrics for the service and say, what's going on here? So this is a lot of information here, but what's cool is we have this group by and filter group by and filter functionality. So for example, Stern mentioned he did an upgrade, right? So let's group by version ID. And so there's now, you can see we have all these different, we have the new and the old, but there's still a lot of lines there. I just want to know about the 500 response codes. So I can filter to that, response code 500. And here we go. So this is the new one, and this is the old one. So like I said, the old one had that one little blip, but that's not bad. That went away. The new one is it's giving us errors and more errors all the time, and this is not good. It's burning through our error budget. So I could worry about debugging the code or whatnot, but right now I just want to roll back. So I go over App Engine, and I can go to the old version, and I can migrate all the traffic. And if we come back here, what we'll find in a minute or two is that we'll see the errors go down, and we'll come back to the SLO page, and we'll see the SLIs going up. But for the sake of we can come back to that at the end. You can see already the SLIs starting to flatten out pretty quickly. So that is the first demo, and let's see what we're going to do next. So features that are going to show up in the next demo include distributed tracing. So just by show of hands, who here's used distributed tracing before? No? Okay, one person. Awesome. Okay, so we're going to display it for everybody else. Like Stern said, I have if I have microservice-based application, he showed one with 5 microservices. But what if you have tens, or some people have even hundreds of microservices? If something is slow, why is it slow? Do you just start at the front end and try to figure out all the way back where the slowness is coming from? That'll take you all day. What distributed traces do is they get a sample. They sample the code, and they basically say, okay, for this transaction, I'm going to trace this one. I'm going to find out how much latency came from this microservice, how much came from this microservice, how much came from this microservice, and it draws a picture. It ties it together into a waterfall, and then you're able to see just at a glance where's the slow span. And when you look at when you figure out which span is the slow one, you can then go into other tools like we'll talk about next to figure out why. So distributed tracing is a really powerful tool for figuring out what's wrong with your microservices. The instrumentation for that is OpenCensus, and that is a vendor-agnostic instrumentation. And we're working with a lot of our partners and competitors on this to make sure that when you can get tracing, it's not just tracing for Stackdriver, but it's tracing for whoever. So if you switch tools, maybe as an ops person, you're switching tools, and that's bummer. But for your developers, they don't care. They still have Census. Now, like I said, what about why is it slow? So once you figure out which span is slow, you can go to the profiler. And the profiler, it tells you continuously, also through sampling, which functions in your code are taking up CPU, which ones are taking up time. You could figure out who your problem child is down to the function level within the microservice. And so that's a really powerful tool that we've released recently. So let's look into a performance issue. Actually, let's see if so again, sorry, just on the last demo, we'll come back at the end. I just want to make sure for time that we. So looking at we're a different service now. We're at default service. So on the default service, you can see again, we wanted less than half a second on 95% of the calls. We were doing good, except for our big test there. And again, the rollout has caused us a problem here. So we can go into the metrics and see what's going on. And this heat map here is showing us that this is where the latency generally was hottest, but now it's up here. And if we want to go even deeper into the more proof, again, we can group by filter ID, group by version ID. And if I look at the old one, that's the latency I want. And if I look at the new one, that's the latency I didn't want. So pretty stark, pretty manufactured demo, but you get an idea of how the tools work and how they show you this stuff. So now, again, I can go and fix the problem. So I can go to the old and migrate the traffic back. And like I said, that'll take effect in a couple minutes. We'll be able to come back at the end of the demo and show you the updated graphs. But I don't want to roll back. I want to know what the heck happened here. So let's go to the diagnostics tab. And in the diagnostics tab, we have traces. And so, all right, this is a 3,400 millisecond trace. That's like 7 times what I set the SLI goal to, or the objective to, right? And the problem could have been anywhere. It could have been in Stern's code, or it could have been in something he was calling. And if you look, here's Stern's code, and here is all the things he called. Well, like data stores behaving really nice. This fetch results function is behaving really, really nice. This is not behaving so nice. So this is where we're going to focus and figure out. So let me call Stern back up, and can you tell us what happened there?
I'll try to diagnose that. I think it's probably not network related. Otherwise, we would see the span on that trace waterfall. So I think this is more code related. Let's dive into Profiler and try to understand where that time goes. So I'm opening Stackdriver Profiler right here. To get it, I open it from the Cloud Console. So this is Stackdriver Profiler that you recently released. What you're looking at here is the heap profile for my application. And usually when I look at such graph, very rich graph, but the patterns I'm looking at are very long spans that are at the very bottom, because that means that one thing is taking a lot of time. So here I don't see that, but I'm looking at heap profile right here. Let's go to wall clock time. This will be CPU, and let's filter out what we call the program frames, which are basically when my program is idle. So this I want to filter out because it's probably when no requests come in. Okay, and right here you see there is something that looks suspicious here. There is this very long span that is named, and the function is named isPrime. Did I just release to production something that computes prime numbers? Sorry, I was testing things, and I'm sorry. Just double check. So I'm going to compare version the old version. Yeah, this one looks like a normal profile waterfall. So this is no long span. And if I go to the new version, then yes, if we look at on the right, we can see like the same kind of CPU usage, but on the majority of our time is spent computing these prime numbers. So I'm sorry about that. I think it's good you rolled it back, and I will remove that from the code. So this is Stackdriver Profiler, continuously profiling my app, really without me having to do anything. So let's switch back. So now, how would I fix that? I would open my editor and simply fix the code itself. Now going back to the last demo, the tools we will use in that demo are Stackdriver error reporting. So Stackdriver error reporting is automatically monitoring your logs for some application errors. So for example, when there is a crash, most of the time in your logs, you will see a stack trace, an exception. And so Stackdriver in real time is looking at all of your logs, looking for crashes. When it finds a crash, it will capture it, and when it finds the same kind of crash, it will group them together, so that what you will focus on when you open error reporting are groups of errors, not single entries, but really they are grouped meaningfully together. So it's all real time, and the way to get it is simply via logging. So that means that on all of our serverless products, because you get logging out of the box, you get also error reporting out of the box. And the second tool I will use in that last demo is Stackdriver Debugger. So Stackdriver Debugger is an amazing technology. I told you before, I'm not able to SSH in my VMs. But that doesn't mean I cannot inspect the state of my instances. And basically what Debugger allows you to do is to inspect the state of a running application without slowing it down. So it's not like a breakpoint. It doesn't stop the execution. No. It's when you put a snapshot, as we call them, it will snapshot the entire state of the app and then continue the execution. But you will have visibility into the state of your application. So we have snapshots, and we have one of my favorite features, which is log points. So how many times did you just redeploy a new version just by adding some log statement because you couldn't figure out what was wrong on production, right? And what Debugger log points allow you to do are simply to add log statement dynamically in your code, without having to redeploy, because under the hood, we are using the exact same technology as for snapshots, which are that every time the code will execute at that point, we will snapshot the state, and we will print a log entry into your logs. So you can dynamically add a log statement to your code without redeploying. To set up Stackdriver Debugger, you have to import a library. This library, when you are not using Debugger, has no impact on your app, and when you're using it, has very, very low impact. So I would recommend to import it in case, for the future, something needs to be diagnosed in production. So my last demo will be using error reporting and Debugger to understand an application error based on an availability alert. So let's switch to the demo. I received this email from Stackdriver telling me that there's a new error in my microservice screenshot. I could also have received a push notification if I was on my smartphone. We have the Google Cloud mobile app, and you receive the same kind of notification on your mobile. So okay, let's click that call to action, view error details. Let me understand what's going wrong here. Let me zoom in a little bit to 1 hour to see better. Okay. So there is a new error. You see it happened 37 times in that time frame. Well, obviously, it's not the first time we see it because we rehearsed. But last seen, it was 10 minutes ago. I think it was last seen when Jay rolled back to the previous version. So it seems that the error is under control. But still, I would like to diagnose it. Well, actually, you know what? Let me roll back to the broken version. Otherwise, the rest of the demo will not work. This was this one, sorry. Okay, so what you see here are the details of a given error group. So at the bottom, you have many samples of that error. You know, I can expand, I can see the stack trace. And at the top, you have a sample stack trace for that error group. And you see we clean it up for you. So we remove the frames that are the Node.js frames, or in that case, it's Express.js. So this is framework code. You as a developer don't want to worry about that. What you want to worry is your code. And this code is in server.js, is my code. All right, so something's wrong. Let's hit auto reload to make sure things. Yeah, you see it start to happen again when I rolled forward to that new version. So let's dive into the code. So I'm just clicking that file, server.js, and it opens Stackdriver debug view. What debug does, it will automatically set a snapshot at this point of the code. So you see, I did not have to provide my code because when I deploy to App Engine, I already push my source code. So Debugger can easily fetch that same source code and allow you to set snapshots on that source code. So let's wait for the error to trigger, or we can trigger it directly by hitting the screenshot service. As you see, it produces an internal server error. And when I do that, okay, the snapshot just hit. And so let's zoom a little bit. What you see, so the snapshot was put here at this line, and here I can inspect the variable. So I see that URL is actually undefined. Well, okay, so now I understand better the URL dot starts with, that obviously cannot be called because the variable doesn't exist, is undefined, so that will crash my application. So, if I want to double check, I can add more snapshots, but at this point, I'm pretty sure about what's going wrong here. So my action, immediately I will roll back to the previous version, and I will fix my code simply by opening my editor. So you see, this was live production code that we inspected, and we got the values of the variables, thanks to Stackdriver Debugger. That's the end of our demos. Let's switch back to the slides for a recap. So the first thing is that we've shown you a little bit about the Stackdriver suite. There are many other things we haven't shown, like alerts. But for you to know, Stackdriver has many tools. We introduced today the Stackdriver service dashboard, SLO monitoring, that are new today, and Profiler was released very recently. Then the other takeaway that we want you to remember is that Stackdriver and Serverless on GCP, this is a check mark. Stackdriver has all you need to monitor and troubleshoot your serverless applications and functions. And for a lot of it, it's out of the box. And lastly, we encourage you to try it out. So on the serverless side, we announced in alpha the serverless add-on for GKE. You can request access. I think, Jay, you want to talk a bit more about the early access program of
so
service monitoring?
The service monitoring, including the SLOs, is in early access. There's a Google form to fill out. If you reach out to reps or to Stern or I, we can get you access to that. All right, so contact, it's Jay Judkowitz, it's my last name at google.com, and you can reach out and I can get you access to the survey so you can sign up for the EAP for service monitoring. Same
for me, if you're interested in the serverless add-on, or try it out on newly released runtimes for serverless. It's Stiran at google.com, my first name at google.com. Feel free to reach out.